Hello guys, welcome to my new study vlog. So today I'm going to solve a medium level lead code question which is integer break, where they have given us an integer n and they asked us to break it into a sum of k positive integers such that k is always greater than or equals to 2. That means we can't return the product as the whole number. We should at least divide it into one time. So that means we should at least divide it into two parts. And they asked us to get the maximum product of those integers. Okay, so they want us to return the maximum product. So in this case, if they have given us the n is equals to 2, we can't return it 2 as it is. We have to return it as 1 plus 1, which is 1 plus 1, and that means 1 into 1 is equals to 1. So 1 is the value that we are going to return. So in the case of n is equals to 10, we have many other options. We can divide it into 5 parts, which is like 2 plus 2 plus 2 plus 2, and which is 2 power 5, that is equals to 32. Okay, but that is not the maximum value. Here we have to take 3 plus 3 plus 4. So 3 plus 3 plus 4, 3 into 3 into 4 is equals to 36. It is the maximum value. So how to do this approach? Earlier I thought of using greedy algorithm, but greedy algorithm is not suitable for this, because we are going to take every number and moving forward, taking it or not. That means two cases, taking it or not, and taking the n possible approaches. That means we are going to take 2 power n into n factorial. So 2 power n into n factorial is not at all a good approach. So this is not the best approach. So I have looked into another possible approach which takes only big of n. So I will try to work on it. So what's the approach is if the number n is divisible by k. So if n divided by k is an integer value, okay, so that means n percentile k is equal to 0, right? So if this is the least possible, easy case. Okay, so if 9 divisible by 3, so it is divisible by 3. That means 9 by 3 is n by k, which is n by k. So 9 by 3, which is equals to 3. Okay, and if n by k power k is greater than greater for a particular k value, then we should take that many divisions only. Okay, so the maximum n by k power k value should be taken. So we will be doing that incremental approach, where max, if it is less than n by k power k, we are going to take it. Okay, but if n percentile k is not equals to 1, okay, not equals to 0, then it's a problem. If n percentile k is equals to 1, that means it is n is not divisible by k, and k percentile value is 1. That means the 10 divided by 3 and 10 percentile 3 is 1. Okay, this is the best example. So the least possible quotient is 3. Okay, so that means what we naturally if the formula for this kind of thing is different from the rest of them, and if n percentile k is greater than 1, then we have to use this formula: n percentile k power k into n percentile n by k. So that means we are going to take the coefficient of n by k, so that should be multiplied. But in this case it should be different if n percentile 3 is equals to 1, because 3 into 3 into 3 into 1 is not better than 3 into 3 into 4. Okay, so 1 has the least multiplication power. Considering other numbers, like even 1.5 has better multiplication power than 1. So in that case, we should add it to the last divisor. That means for the last divisor, we are going to take 3 plus 1. Okay, so that means our approach will be like n power n by k power k minus 1 into n percentage k plus 1. So that will be for this case. So considering these both formulas, we will solve it. So for this question, I have tried to apply greedy algorithm earlier, but it was not successful, because greedy algorithm in this case we have n outcomes. So n outcomes, that means we are going to take any one of the case. In the case of 10, we can take 2. or not take it. So that means we have two outcomes for 2 itself, and that in the same way we'll have 2 power 10 outcomes for the 10 numbers, and selecting one of them will be like nc1. So selecting one of the one of them will be like nc1. That means we are going to divide our parts of the code into 2 power n. So that's very high in terms of time complexity. Optimal solutions normally should be like n log n or n square, but that's why we should not consider greedy algorithm. It's not right to take data structures for granted every time. Software engineer needs to think logically, so logical thinking is always important. So data structures will give us an idea on how to approach a kind of problem, to look out all its parameters, but logical thinking is very important. In order to implement certain parts of code, we definitely need logical thinking, especially for the kind of questions where we have only one number n. So never forget that. So I have tried like the same approach. If n divided by k is equals to an integer, so then that means n is divisible by k. Then we have to take that formula which I have mentioned, and if there is the remainder 1, and the third case will be like the remainder greater than 1. So greater than 1, as we have discussed, we will multiply it. If it is less than 1, we are going to definitely divide it and take the last part and add it with 1 and give the result. But only 8, the n is equals to 8 case is not satisfying, because the step value of the remainder which we are going to get is very near to the n by k. So the remainder is near to n by k. So in that case, what we should do, we should take math.ceil and take the maximum possible divisor, not the one which you get. So especially for the value n is equals to 8, that means we are going to get the next error in 64, but our the boundary conditions for n they gave is only 58. That's why we are not going to get the error for 64 as well. But we should solve that case. That's why I have used the math.ceil and took the math.max of both non-sealed divisor and sealed divisor, so and found the answer. Finally it worked well. Thank you.